I've increased my 3D print strength by 5x. This is Dave in the Shop. Stay tuned, and I'll tell you how. As you recall in the previous video, I designed this little small test part, C-shaped part, to use to test the strength of materials. Well, in that last video, having a friend of mine also make some of the parts and pieces, we determined that my parts and pieces were nowhere near as strong as his parts. And his parts ended up being 2.5 times stronger than the parts that I have. Now, when it comes to part strength, when we compare parts that we printed before and then parts that we're now printing, these being printed with the same 15% infill, we did find that we got a 5x increase in strength. And the big factor on this turned out to be a factor in the slicer called the multiplication factor. With close examination of the parts from before, we could see all sorts of little gaps in here. You could see that the extrusions weren't the side by side, they weren't touching together, they weren't merging well. At the end of an extrusion or end of infill, it wasn't meeting up with the outer shells well. And we found that that was under extrusion. So the multiplier factor allowed us to it's a correction factor. It allowed us to increase the amount of extruded material. And now the extrusions all touch side by side. The gaps fill in, and we saw that the part got significantly stronger when that occurred. So over the last few days, we've made hundreds of parts and run those through the testing machine, varying a lot of different settings and determining what is stronger, what is weaker, and came up with a set of settings for my machine that I think are yielding the strongest parts. So in this process, we tested a lot of parts. We broke a lot of parts. But what we did was we documented the settings for the printer, we documented infill, we documented the materials that we use, and we learned a lot of different things. So we certainly learned some characteristics between a few different types of materials. Now, mostly we were doing PLA, but we also did a little bit of PETG in this testing. And we did find some wide-ranging results in these tests. And we found some things where we thought we understood or presumed we understood that certain materials were better than others, and all of this testing and the control situation that we did. Now we got a better understanding, and some of those things, maybe myths, aren't true. So now we got a way to continue to check out parts and determine how strong. The goal in this is how to make the strongest part. So that's what we set out to do. That said, let's see what part we can put the maximum tension on, change up the settings, test it again. Again, we've tested hundreds of parts along the way in this process. So one of the things that we saw, the characteristic we saw, was that some parts, they will snap in two. They'll break. They'll snap all at once, kind of violently. And some parts stretch and tear apart, and they tear slowly. While making all these parts, what we found was that matte PLA, PLA Pro, and PLA Plus, those parts tended to tear apart. And then with PLA, just plain PLA, and PLA glass, what we found was those parts tended to fracture. Also, physical appearance of those parts, the matte PLA, PLA Pro, and PLA Plus all had a matte looking finish, not reflective, not shiny looking. So now that I believe that I've got my slicer all dialed in. I'm producing parts that are equal or stronger to the machines that are coming off the Prusa. Again, using the default settings on the Prusa, so we haven't tried to maximize strength on it. But my machine is producing good, strong parts. I'm confident in what's happening on that machine now. All right, let's talk a little about the results. When we first started, these PLA parts, basically everything averaged out to around a 25 pound brake strength. So not very good, not very good indeed. After we made some changes to the multiplier, changing that from 0.9 to 1.05, our best part was 91 pounds. So that's almost 4x right there, just making that one change. A couple other small changes that we did was the change in the infill. So moving from 15% infill to 80% infill, then that took us to around 125 pounds for the brake strength. And then one other small change was sidewalls, and so we made a change from 2 sidewalls that we'd been using in all of the parts, and made a change with 4 sidewalls. It got a little better, and then 6 sidewalls, so 80% infill with 6 sidewalls with our new settings on it, and that gave us 134 pounds on the maximum brake strength. Now, the machine was kicking and bucking, and we were I don't know that measurement is really the full strength, but that's all we could get out of the machine at that time. So we've got some parts that are at the maximum limit of this cracker machine, and part of that is due to the torque that this particular stepper motor can provide. Part of it is this wooden frame that it's built out of. I had to glue part of it back together because the plywood started to delaminate. So we were breaking parts. Maximum on this we got was around 134 pounds breaking strength on the part. So as we continue down this journey and look to continue to make parts stronger, trying a few other we got a few other things, a few other parameters that we want to do, and a few other materials. We're going to have to make a stronger machine. So I've got some aluminum plate, and so basically everything you see here that's made out of wood will get, I'll take that over to the CNC machine, and I will make that out of aluminum. And then we've got a new motor that's basically about twice the torque, and we'll put that on, and that should give us a more rigid frame that we can generate stronger pull. We're good on our load cell and that little Arduino project to control the load cell that's in the previous video. That's working out great. So we've been capturing the max load, I think, very successfully. And we've still got room in this load cell. It is rated for 100 kilograms. I don't know if you can read that, but 100 kilograms, 220 pounds roughly. And so we'll go build a bigger frame. Hopefully we can get our motor to be able to pull that full amount up to the limit of the load cell. So that's where we're at. That'll be the next build project, is to put that together, and I'll show you how we go about that, kind of the high level video of the build for that project. This is Dave in the shop. Thanks for joining me. Remember, like and subscribe. That really helps out the channel. We'll see you in the next video.